Dr. J, what exactly is an intermolecular force? So an intermolecular force is basically holding those molecules together. All right, they're always holding them together. And we have four intermolecular forces we're going to cover. Okay, so the first being we have ion-dipole forces. Okay, or you might hear me say interactions, right, or attractions. It's the same type of deal, right? We know, right, that they're interacting in some way. So ion-dipole, okay, we're really talking about ions interacting with each other. Okay, so example, right, is like sodium and chlorine coming together, in water, of course, as those ions are going to interact. And this force, right, has a certain and strength to it, which will break these down in a bit. The second force is what we call dipole-dipole. Okay, so dipole-dipole attractions. Okay, and we're really going to see these type of intermolecular forces with polar molecules. Okay, so polar molecules are very big with dipole-dipole attractions. Next, we have hydrogen bonding. Okay, so hydrogen bonding is basically it's a special dipole attraction in the molecules where specifically, and this is a huge hint, hydrogen is involved. Okay, so hydrogen must be involved for hydrogen bonding. Now, specifically, the hydrogen will be bound to an electron negative atom. So we're thinking about oxygen, fluorine, etc., right? Those top right elements up there. And then these are two factors that are going to be pretty impactful when we're talking about hydrogen bonding. One is the size of the hydrogen. Well, that's a big factor, right? Because it's always going to have hydrogen, right, with these type of interactions. But we know, right, and we understand that hydrogen is very small. Okay, so since hydrogen is very small, okay, that's going to allow a different type of attraction, right? So basically, they can get a little bit closer, unlike other reactions that we see with our ions or other polar molecules. But also another key thing, right, is because this hydrogen is bound to electron negative atoms, it has a huge difference, and because of this huge difference, um, that's a key factor that makes attraction stronger, okay, because of this difference. And then lastly, we're going to talk, we have London dispersion forces, okay? So these are different from the others. One reason is that they're temporary, okay? So these are temporary dipole moments, okay? And these are forming when our electrons, right, they're not symmetrical at all, okay? So key thing with this, and we're going to see this, is that basically all molecules can have London dispersion forces. Okay, so at some point in time, polar molecules, non-polar molecules, etc., right, they can have London forces. That's key thing to understand. They can have these forces.